Good morning, third grade. So today in math, we are doing Unit 10, Lesson 9, which is on page 83 in your student journal book. And we are studying the concept of relating the distributive property to area. That is our objective. So how are the distributive property and the area related to one another? So we will get to that in a few minutes, but before we do that, we are going to solve a problem of the day. And I put my problem of the day on a new piece of paper to give you a little bit more space. So what I want you to do right now is grab a pencil, and in that problem of the day section, I want you to go ahead and draw this figure right here that I have. So pause the video, draw this, and then you will be ready with me. So you should have paused the video, and now you're with me. So if we look at this, we see that we have a shape. And we have a shape that has some sides that are known because it's giving us the measurement, it's giving us the lengths of the sides, but we also have two sides that are unknown, and we need to figure these out. So in order to help us figure that out, we are going to use our bar model that we have used for a lot of board problems throughout our year. And our model shows that our top is the whole, and that our bottom two sections are the parts. So we know that if you are missing the whole and you have both parts, a part plus a part equals the whole. We also know if you have the whole and you have a part, but you are missing the other part, then the whole minus the part equals that missing part. Why? Because we are finding the difference, and you subtract the whole from a part in order to find what is missing. So we can use that today to help us solve for these unknowns. So let's go ahead and let's start with this x right here. This is what we're solving for. So we had to figure out what we know here. So what do we know? Well, we know that this area right here, this area is equal to 9, okay? And I am looking for this. So if I combine these two together, okay, 9 and something, okay, one part is 9, one part is something, are unknown, okay, that'll help us figure it out. Well, what do we know? Let's look parallel. Let's look over to the other side. That section is the same as this section, which is equal to 16. This length is the same as this length, okay, so we need to use these numbers that we have in order to help us solve for x. So what do we know? Well, we know that our whole is 16. We know that our part is 9, and we have a missing part. So there's two things we can do. We can either do, here's my pencil, 9 plus our part equals our part, right? A part plus a part, equals our whole, which is 16. Or we can do 16 minus 9, okay, our whole minus our part to get to x. Because whatever x is, we need to figure out using what we know, our whole and our part. So I want you to think about that for a second. And whichever way you solve, you should all come to the conclusion that this x right here is equal to 7. Why? Because 9, that part, plus this new part that we found, 7, is equal to 16. This length is now the same as this length. 9 and 7 all together are equal to 16. Now let's go ahead and look at this, okay? Well, let's see what we know here. We know that this section down here, this whole section down here, is equal to 14. Okay, so that's equal to 14, this whole thing. So what we need to figure out for this is, what's this? Well, if I know that this is 3, I know that that's 3. Okay, so now I know that this length is the same as what this whole length would be. So now we're missing a part, aren't we? We know that the whole is 14. We know that that part of the whole is 3. So what is this x here? Remember, our whole is 14. This guy right here, because that's part of our whole, is 3. So x plus 3, something, plus 3 is going to be equal to 14. Okay, whatever that missing part is will be this section. So let's go ahead and fill in the blanks. We can either do up here something plus 3 equals 14, Or we can do our whole 14 minus our missing part equals the part that we know. So think about that. And if you're with me, you should get x is equal to 11. Let's check our work and make sure. If this is 11, and I know that this guy right here, this part right here is 3, 11 plus 3 is equal to 14, which is our whole. Okay? So we are going to be getting into that tomorrow, so I wanted to kind of show you it right now. Actually, next week we will be, but we'll go over another problem like this tomorrow. Okay? So now on to the distributive property for area. If you're on my phone call with me yesterday, we went over this and we said A times B plus C, that's the distributive property. When we've been doing the distributive property lately, we know that our factors, for example, A times D, those are two factors. We know that we can break down one of our factors into two addends. And then what we did was split it up. A times B plus A times C. So we took our fixed factor, this one's fixed because it didn't change, and then our two addends, and we distributed A times B plus A times C. Okay, A times B plus A times C. So let's go ahead and do that with this problem. Let's look here. I think the easiest thing to do is use, I'm going to erase so you can see, the distributive property of area and fill in the numbers. So kind of fill in the blanks, or use the letters here to fill it in. So we have two different rectangles here that are combined together to get one larger rectangle. With the distributive property, we take the area of both rectangles separately and then we add them together to get the total area. That's what we're doing. So if we take this, we know that A is our fixed number. It's our number that doesn't change. And for this particular problem, our fixed number for both of these is 5. So we have A here, okay? B is the length of one of our rectangles. C is the length of the other of our rectangles. We know that these two combined together, kind of like what we just did in the problem of the day, 3 plus 8 is 11. That's the whole. But separated into two separate rectangles, we have B and C, 3 and 8. So we're going to plug in 5, that's A, times B plus C, which is 3 plus 8, is equal to 5 times 3 plus 5 times 8. So 5 times 3 is 15, and 5 times 8 is 40, just like we've been doing. And then we add them together. 15 plus 40 equals 55. So basically all you did was you found the area of one of the rectangles, and then you found the area of the other rectangle, 5 times 3, and then 5 times 8, added them together to get the total area of this entire figure. So let's go ahead and get started and practice together. If we look here, what is the total area of the shape? Fill in the blank to find out. We have two separate rectangles here. Okay, we have one here, this is A, or actually I'm going to call this rectangle 1. We have another rectangle here, rectangle 2. We need to find the two separate areas using the distributive property in order to find our total area of the whole thing. Let's find out what our fixed number is, our A. So A times B plus C, that's the distributive property. So A is what's fixed. That's what doesn't change. Well, in both of my rectangles, in rectangle 1, my A is right here, okay? 1, 2, 3, 4, 5, 6, 6 by something. And in rectangle 2, my A is also right here, 1, 2, 3, 4, 5, 6. Okay, it's fixed, it doesn't change. It's 6 on both rectangles, okay? Now we have to find B and C. So B is 1, 2, 3, 4. So A and B. And then C is 1, 2, 3, 4, 5. Okay, so let's look over here because now we're going to take our fixed number and we're going to distribute it. A times B plus A times C. A times B plus A times C. Okay. Our fixed number, just like I told you, is 1, 2, 3, 4, 5, 6. They already did that for me. 6 times length times width. 1, 2, 3, 4. So B is equal to 4 plus 6. 1, 2, 3, 4, 5, 6 times, what's the width of my second rectangle? 1, 2, 3, 4, 5. 5. So this would help solve, this would solve the area of my first rectangle, and this would solve for my area of my second rectangle. 6 times 4 is 24, plus 6 times 5 is 30. So together that is equal to 54. Okay, length times width equals area, length times width equals area, and we added each area together in order to get our combined area. All right? My second one. What is the total area of the shape? Fill in the blanks to find the area. Well, if you notice what's similar about these two, they're exactly the same. So our answer should be the same, but we're using a different way to get there today with this one. So A times B plus C, that's the distributive property, okay? So now what we need to figure out is what is our fixed number? What's the number that doesn't change in both of our rectangles? Well, we already solved. It's 1, 2, 3, 4, 5, 6. Okay, my length for both rectangles separately, rectangle 1 and rectangle 2, my length is 6. Times B plus C. Those are my two widths. That combined together will help me to find my total. So B is 1, 2, 3, 4 plus C 1, 2, 3, 4, 5. Okay? Because we know that 4 and 5 is going to help us find our whole. Okay? So 6 times 4 plus 5 is 9 equals blank. Okay? This is our new area formula. Length times width equals area for our whole entire thing. Let's see here. Now we're looking at our whole shape. Not separately, but together. I have A times B plus C. So B plus C is 9. 6 times 9 is 54. Okay? So if you look at your structured guided practice here, again, A times B plus C. You need to find what's fixed, and guess what? It's already there for you. You know that in both of these rectangles, you have a length, or actually a width of 3. A width of 3. You have 3 here, and then you also have 3 here. And then you need to find what your missing B is and what your missing C is. Okay? So A times B plus A times C. That's the distributive property. Okay, so I'm going to help you. Here's A, here's B, and here's C. So in order to find the area of the first, you're going to do A times B plus A times C. Okay? And then my last one, you should have the same answer because these are exactly the same. A times B plus C. That's the distributive property. You already have it labeled up here. It's identical down here. But this time, you're going to put B and C and then add them together to get to your new factor. All right? So I want you to try that on your own, and I want you to go ahead and post page 86. It's 86 in your book, the student practice page. I'm here if you need me. I know this is a little tricky, but you can do it. Okay, you can do it. I will talk to you later. Have a good day.